Let's now look at a related rates problem about pulling a boat with a winch. We're told that a boat is being pulled towards a dock by a rope attached to a winch, and that winch is 5 meters above the water level. The rope is being wound in at 2 meters per second, and we want to find how fast is the boat approaching the dock when 13 meters of the rope is out. I put a diagram down here, put a little boat. That's about as good as I could draw it. And now let's go ahead and let's label things. This right-hand side is our winch. And then this distance here is our rope. And then this point here is our dock. Our boat is heading towards the dock. Now what we need to do is assign variables to our diagram. We are told that the winch is 5 meters. So we're going to label this distance 5 meters. The distance from the boat to the dock is changing, so we're going to let that be variable x. And then the length of the rope is changing, so we are going to let that be the variable capital R. Now let's write down what we're given. We are told that the rope is being wound in at a rate of 2 meters per second. So we can say that dr dt is equal to minus 2 meters per second because the amount of rope is decreasing. We want to find how fast the boat is approaching the dock, so that is going to be dx dt. And we want to know that when 13 meters of the rope is out, so that is going to be when r is 13 meters. Now what we need to do is find an equation that is going to relate capital R and x and the length of our winch, which is 5. So we need to relate x, r, and 5. That equation comes from the Pythagorean theorem because we have a right angle here. So we have x squared plus 5 squared is equal to r squared. So we can write this as x squared plus 25 is r squared. We're now going to take that equation and we are going to differentiate it with respect to time. So let's write down x squared plus 25 is r squared. And we're going to take the derivative with respect to time of both sides of our equation. So this derivative is 2x times dx dt plus the derivative of our constant, which is 0. And then on the right-hand side, we have 2r times dr dt. We want to find dx dt, so we're going to solve for that. So we have dx dt is equal to 2r times dr dt, all divided by 2x. Our 2's cancel, and we end up with r times dr dt, all divided by x. We want to find dx dt when r is equal to 13 meters. Notice up here in our equation that we can substitute in that r is 13. We are given dr dt, however, we do not know what x is. So we are going to have to use our equation x squared plus 25 is equal to r squared to find what x is. Let's go ahead and let's do that down here. I'm going to write down that x squared plus 25 is equal to r squared. Let's substitute in that r is 13. So we have x squared plus 25 is 13 squared. And we know 13 squared is 169. So x squared is 169 minus 25, and that is 144. And so x is equal to 12. And we'll go ahead and put a unit there. It is in terms of meters. Now we can go ahead and go back up, and we can plug in everything up into that equation. Our r is 13 meters, and then dr dt we were given up here is minus 2 meters per second. And then we just found that x was equal to 12 meters. So this is minus 26 over 12 meters per second, and we can divide by 2 in both of those. So we get minus 13 over 6 meters per second. Whenever you solve a related rates problem and you get a negative, you need to go back up to the original problem and find out what you're being asked to find. We want to find how fast the boat is approaching the dock. So that means the distance from the boat to the dock is decreasing. And that's why we got a negative answer. And we can write our answer and we can say that the boat is approaching the dock at 13 over 6 meters per second. And let's go ahead and highlight that answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.